All right, so we are going to be talking about systems of equations. Now, this is something we talked about last year in Secondary Math 1, so it should look familiar to you. Systems just means more than one, okay? And actually, let me adjust this really quick so I'm not hitting the camera every time. Okay, much better. Okay, so systems more than one. Okay, so we're either graphing or we are given more than one equation. Okay, well, let's look at 1 and 2. These are actually not systems because we're only given one equation. Okay, so what we're going to do with 1 and 2 is we are going to change them from standard form, which they are in now, to slope-intercept form. We love slope-intercept form because it tells us our slope and our y-intercept. Okay, let's remind ourselves what slope-intercept form looks like. Slope-intercept form, always looks like y equals mx plus b. So that's what we're trying to make it look like. We need our y all by itself. Okay, so let's look at number 1. Okay, and I'm just going to go ahead and rewrite it over here so we have some space to move. Okay, so we have x plus 5y equals negative 5. So we want to get y by itself. So we need to move this x and this multiplied by 5. Okay, well, moving the x, that's what we need to do first because it's farthest away from my y. Okay, and just think of this as a positive x. Well, the opposite of a positive x is a negative x. Okay, so we're just going to move it over here. So now we have 5y that's left over here. And I'm going to put my x first because that's the way it works in the slope-intercept form. Negative x minus 5. Now remember, we cannot combine those guys because they're not like terms. Okay, now my last step. I have 5 times y, so I need to get rid of times by 5. Okay, well, the opposite of times by 5 is divide by 5. That means we have to divide everything on this side by 5. So now we can kind of clean this up a little bit, do some simplifying. So y equals, it's all by itself, which is great. That's what we want. Okay, so this guy turns into actually a negative 1/5 times x. That's the same thing because there's an invisible 1 right there. And then negative 5 divided by a positive 5 is going to give me a negative 1. And there we go. We changed it from standard form, which it started in, to slope-intercept form. Okay, so let's go ahead and graph it now that it's in slope-intercept form. Okay, because we know our slope and we know our y-intercept using our new green equation. Okay, so our slope, remember, is always right in front of our x, so it's negative 1/5. And our y-intercept is the number on the end, negative 1. Okay, when graphing these guys, you always start with your y-intercept. That's an actual point on the y-axis, the y-intercept. So find negative 1 and put your first point. Okay, now we're going to go ahead and use our slope to count to our next point. So this is going to be a negative, so we're going to go down 1 and over 5. Remember, rise over run. So down 1, over 5. 1, 2, 3, 4, and 5. Okay, 2 points. Connect them with a straight-ish line. Arrows at the end because it goes on forever, and we are done. Okay, let's do that again for number 2. So I'm going to just go ahead and rewrite it over here. Give ourselves a little more space. 2x plus y equals 1. Okay, well, the first thing I got to get rid of is that's farthest away from my y, because remember, we're trying to get y by itself, is actually the 2x. It's this whole piece, and we can move the whole piece. Okay, well, the opposite of a positive 2x is a negative 2x. So we're going to subtract it, and that moves it over to that side. Okay, so now what we actually have is our slope-intercept form because y is all by itself. Okay, positive y is just y. Okay, remember, you always want to write your 1 with your x first, so we have negative 2x and then a positive 1, which was already over there. Beautiful, and we're done. We rewrote it from standard form to slope-intercept form. So now we can graph it because this tells us our slope and our y-intercept. Okay, so remember our slope is always right in front of that x, so our slope is -2, or if you want to help yourself, we can write it as -2/1 to help with rise over run. Okay, then our y-intercept is the number on the end, so that's just +1. Beautiful. Okay, so let's go ahead and find +1 on our y-axis. That's going to be right there. Now I'm going to use my slope, -2 or -2/1. So now we're going to go down 2, 1, 2, and over 1. Connect those 2 points. Remember, a negative slope is always going down and to the right, which this is, so we are good to go. Beautiful. Okay, now looking at 3 and 4. Now we're getting into systems because we have more than one. We have 2 now. Okay, so we're just going to treat this like graphing two equations. Okay, we're going to take it one equation at a time. So first, let's start with we'll call this our purple equation, the top equation. Okay, so let's go ahead for the top equation, identify the slope and the y-intercept. And remember, this is review from last year, so it should look familiar. Okay, so our slope for our purple one is always right in front of the x, so that's going to be 3/4. And our y-intercept is the number on the end, -2. Okay, so let's go ahead and graph it before we look at the other guys. So my y-intercept's -2, so find -2 on your y-axis, right there. And we're going to use our slope of 3/4 to count to our next point. So this is a positive 3/4, so we're going to go up 3, 1, 2, 3, and over 4, 1, 2, 3, 4. Okay, beautiful. And just to give us one more point, let's see if we can go backwards. Okay, so let's go instead down 3, 1, 2, 3, and over 4, 1, 2, 3, 4. Notice I'm still creating this straight line, but with a system, we're trying to figure out where they intersect. So giving yourself a few more points on the graph is a good idea. Beautiful. Okay, well now let's look at our second equation. We'll call this our green equation. Okay, so let's identify our slope and our y-intercept for our green equation. Okay, so my slope is right in front of the x, so this is a -1/4. And my y-intercept is +2. Beautiful. Let's go ahead and graph this guy. So my y-intercept is +2, so find +2 on your y-axis. And now our slope is negative, so we're going to go down 1 and over 4. 1, 2, 3, 4. Beautiful. Turns out we didn't need to put that extra point, but it's always a good idea. Because remember, the solution, the answer, is not the graph, okay? We just use the graph to find the answer. The answer is where they intersect. It's this coordinate point. So now we write it as a coordinate point, x comma y. So line it up with your x, lines up with 4 on my x-axis, and lines up with 1 on my y-axis. So my solution is 4, 1 in parentheses. Beautiful. And we are done with that. Let's go to number 4. Do it again. Okay, so let's take our purple line, top line, identify our slope and our y-intercept. Okay, so my slope is always right in front of my x, so this is going to be 2/3. And my y-intercept is the number on the end, so 1. Okay, so let's go ahead and put that on our graph. Find 1 on your y-axis, +1. It's right there. Now we can use our slope to count to our next point, rise over run. So we're going to rise 2, 1, 2, and run 3, 1, 2, 3. Okay, remember, it's always a good idea to give yourself another point. So maybe go backwards. Go down 2, 1, 2, and back 3, 1, 2, 3. Still a straight line. Still a positive slope because it's going up and to the right, so we're good. Okay, now let's look at our green line, bottom line. Let's identify our slope and our y-intercept. Our slope is the number right in front of the x. This one might be a little tricky, but this is actually a -1. Okay, and we can rewrite that as a fraction to help with rise over run, -1/1. And our y-intercept is -4. Okay, so let's go ahead and graph this guy. Find -4 on your y-axis. And that is right down here. And now we're going to use our slope to count to our next point. So we're going to go down 1 and over 1. Whoops. Okay, I don't have a point where I'm going to connect, and I can't go down 1 over 1 anymore. So now let's go backwards with this guy. Let's go up 1, back 1, still creating that straight line, still creating a negative slope. Up 1, back 1, one more time, up 1, back 1, and bingo. Okay, so remember, the graph is not the answer. We just use the graph to find the answer. So our answer is this coordinate point where they intersect. Okay, so we always write it as x comma y. Okay, it lines up with -3 on our x-axis and -1 on our y-axis. So our answer is -3, comma, -1 in parentheses. Beautiful. Okay, let's do 2 more examples. Actually, 4 more examples. We'll see which ones I want to do. Alrighty, so number 5. Again, let's just start with our first equation. So we have our slope and our y-intercept. Okay, so our slope again is that -1 right in front of our x, or -1 over 1 to help with rise over run. Y-intercept is also -1. Okay, so we can go ahead and graph this guy. So find -1 on your y-axis. It's going to be right there. Now I'm going to use my slope, which is -1 over 1, down 1 over 1, and let's give ourselves a few points. Maybe over here, down 1 over 1, and we can go backwards, up 1, back 1, up 1, back 1, up 1, back 1, up 1, back 1. Okay, still creating that straight line, still creating that negative slope that we need, so we are good. Okay, now let's look at our green line. Identify our slope and our y-intercept. So my slope, right in front of my x, 3 over 2. And my y-intercept, +4. Okay, so we always start with our y-intercept, so find +4 on your y-axis. It's going to be right there. And now let's use our slope to count to our next point. So this one wants us to go up 3 and over 2. But I can't go up 3. I'd run out of room on my graph. So instead, we're going to go backwards. Down 3, down 3, 1, 2, 3, and back 2, 1, 2. We have to go backwards to create a positive slope going up and to the right. Okay, so we found the answer where they intersect. Okay, remember it's a coordinate point. That is our answer. That's what we're trying to look for. Okay, so it lines up with -2 on our x-axis and +1 on our y-axis. So our answer is parentheses -2, comma, 1, close parentheses. Beautiful. All right, number 6. Let's do that again. So we have my purple line, which we can identify our slope and our y-intercept. Okay, slope is right in front of my x, which is a -2/3. And my y-intercept is +4. Okay, so let's go ahead and graph this guy. Find +4 on your y-axis. That's going to be right there. And now this guy wants us to go down 2 and over 3 to give me that negative slope. Down 2, 1, 2, and over 3. 1, 2, 3. Okay, so that's about as many points as we can put on there without running out of room. So we're good on our purple graph. Now let's look at our green one. Okay, so I have a slope and y-intercept. My slope is 2, or we can rewrite it as 2 over 1. Remember, just put it over 1 to create a fraction. And my y-intercept is -4. Okay, so find -4 on your y-axis. It's going to be right there. And now our slope is +2/1. So we're going to go up 2, 1, 2, over 1. Still not connecting anywhere, so let's keep going. Up 2, over 1. Up 2, over 1. And there we go. Okay, so we found the point where these two lines intersect. Okay, so this lines up with 3 for our x. Remember, x always comes first. And 2 for our y. So coordinate point 3, 2. Beautiful. Let's do 2 more examples. Okay. So we have our top one, slope and y-intercept. Okay, my slope for my purple guy is 1/4. And my y-intercept is a +2. Okay, so we're going to find +2 on our y-axis. That's going to be right there. And we're going to go up 1 and over 4. So up 1, over 1, 2, 3, 4. Okay, maybe let's go backwards just to give ourselves another point. Down 1, back 4. 1, 2, 3, 4. Still creates that straight line. And there we go. Okay, now let's do our green line. Slope and y-intercept. Okay, so again, my slope is 1/4, and my y-intercept is +4. Okay, so let's find +4 on our y-axis. It's going to be right there. And we're going to go up 1 and over 4. Up 1, over 1, 2, 3, 4. Still not seeing where they connect, so let's go backwards. Down 1, back 4. 1, 2, 3, 4. What is happening with these two lines? Okay, so do they ever intersect? No, they never intersect. These lines are what we call parallel. I think I spelled that right. Okay, so when they never intersect, they're going to go on forever and ever and ever because they have the same slope. So whenever you see that the slopes are the same, no solution. Or maybe it wants you to write DNE for does not exist. Okay, awesome. Number 8 is kind of like the others, so we don't need to do that one. So that'll be it for your notes today. There is an assignment that goes with it.